Hey guys, welcome back to the LearnAP Calc series here at LearnAP. Today we're going to go over advanced topics of derivatives part 2, so continuing from our last video. Today we'll talk about the mean value theorem, Lhopitals Rule, and recognizing limits as a derivative. If you guys have any questions, be sure to leave a comment, or you can also ask in our weekly live streams we do every Sunday from 4 to 5 p.m. Eastern. Other than that, we'll get started. Alright, so let's start by talking about the mean value theorem. The mean value theorem states that if f of x is defined on the interval a to b and is differentiable on our interval a to b, then one value c exists between a and b such that the derivative of f at the point c is equal to the average slope, or f of b minus f of a, all over b minus a. And this is a little wordy, but it's important that you understand it. So if I quick draw out a graph, I'll call this point A, I'll call this B, and I'll say that my slope here, this is my f of b minus f of a all over b minus a. That's my average slope between the points A and B. Now, all the mean value theorem says is that at some point, I'm going to hit a value of c, where the slope at that point is equal to my average slope. So that's all the mean value theorem says. It's important to note that this only exists if the function is differentiable and defined on my interval. So the AP test might try to catch you on that, but just remember, mean value theorem, differentiable and defined. Alright, so now let's talk about Lhopitals Rule. Now, Lhopitals Rule is a really easy way of solving indeterminate limits. So given that the limit as x goes to c of some function over another function equals 0 over 0, then that limit is equal to the limit as x goes to c of the derivative of f of x over the derivative of g of x. So you can use Lhopitals Rule if both f of x and g of x are differentiable at c. If it is not, you cannot use Lhopitals Rule. It's also important to note that you can only use Lhopitals Rule if your indeterminate form is 0 over 0 or infinity over infinity. Now, I talked about earlier that we have these other indeterminate forms, and I told you not to worry about them. Well, now you should know those. And note that if you get one of these, you have to try to convert it to 0 over 0 or infinity over infinity to use Lhopitals Rule. Alright, so let's do two quick example problems. So find the limit as x goes to 0 of sine of x over x without just knowing it. So use Lhopitals Rule to actually find it. And then find the limit as x goes to 0 of x to the x. So pause your video, unpause when you think you found the solution. Okay, so our first one is pretty straightforward, because when I plug this in, I'm going to get 0 over 0, so I can just take the derivative of the top and bottom according to Lhopitals Rule. So derivative of sine is cosine. The derivative of x is just 1. Now I can plug this in and see that it's in fact 1. So you should have just known this right away was 1, but you can very simply find it using Lhopitals Rule. Now the second one you might have had some trouble with, and it's not very easy to do. So if I plug this in, I'm going to get 0 to the 0. Now this is indeterminate, but it's not 0 over 0 or infinity over infinity. So I have to get it to one of those forms. And the way that I do that is I say that y equals limit as x goes to 0 of x to the x. Now take the ln of both sides. And now, according to my log rules, I can say that this is x times ln of x. I'm just taking the log of this and then moving my exponent down. Now, if I do a little more work, I can say ln of y equals limit as x goes to 0 of ln of x over 1 over x. And this is going to give me infinity. Don't write equals sign for indeterminate forms, just write it like so. And so now I can use Lhopitals Rule. ln of y equals the limit as x goes to 0 of 1 over x over negative 1 over x squared. And now if I sort of simplify this one, I can get that this is 1 over x all over 1 over x times negative 1 over x. These cancel. I can rewrite this as limit as x goes to 0 of just negative x, which gives me 0. And now, again, this is ln of y, so solve for y equals 1. And so how I found that is I'm saying ln of y equals 0, e to the 0 equals y equals 1. So that's a common mistake, is that you get 0 and you say, okay, my answer is 0. But if you're taking the ln of y, you then have to solve for y. So just important to note that common mistake. Alright, so let's talk about an important shortcut you should know, and this is recognizing a limit as a derivative. So this top limit here, limit as x goes to 0 of e to the 5 times x plus 2 minus e to the 10th all over x, is sort of a tricky one to do. But you can recognize this as the limit definition of the derivative. So let's write out the limit definition of the derivative of e to the 5th. So it would be limit as h goes to 0, e to the 5 times x plus h minus e to the 5x. And now if I plug in 2 for x, I can see, in fact, that this is the same thing as over here. So what that basically means is that this is asking for the derivative of e to the 5th at x equals 2. So h plus 2, again I'm plugging in 2 for x, and this is what I end up with. And it's just that our variable here is x and here is h. And so if you immediately recognize that this is f prime of 2 for f of x equals e to the 5x, then all I have to do is take my derivative and plug in. And so that's a useful shortcut to know, is to recognize something like this as a derivative. And normally the dead giveaway is x going to 0 all over x. And then you have pretty similar terms being subtracted. So that's just something to look out for. Alright, so that brings me to today's challenge problem. Find the limit as x goes to infinity of 1 plus 1 over x all to the x using Lhopitals Rule. So if you recognize what this is, just do Lhopitals Rule and sort of prove the value that you know. The solution to this problem is on our website, LearnAPCalc. I'll also include a direct link in the description. If you guys found this video helpful, please like and be sure to subscribe for future content. Like us on Facebook and follow us on Twitter for updates about our new videos and live streams, which we do every Sunday, where we answer your questions about AP Calc. Links for that will also be in the description. If you guys are looking for extra resources to help you learn AP Calc, be sure to check out our resource recommendation video. Link to that will be in the description. Leave a comment if you guys are still confused about any of this, or also any other comments on the video in general. Other than that, I want to thank you guys for watching, and I'll see you in the next video.